So my name is Sudarshan. I'm the co-founder of Albatross Energetics. At Albatross, what we do is we build energy-efficient air conditioners using liquid desiccants. So when we think of air conditioners, thank you. So when we think of air conditioners, we tend to think of temperatures like 18, 20, 24 degrees and all of that. But air conditioning by definition is about three things. First, next slide please. So first is the temperature, next comes the humidity control, third comes the air purity and air quality control. And humidity is something that existing ACs are, so humidity is something that existing ACs are very inefficient at controlling. And in a world that's becoming increasingly humid, this factor is going to affect the performance of air conditioners. And that's the reason why we see that a few technologies, or particularly one particular technology is gaining traction in the world of HVAC, which is desiccant-based air conditioning. So how desiccant-based ACs differ from a normal AC is that when we think of a normal air conditioners, be it the one in our homes or one in commercial facilities like this, they often will have to overcool the air to squeeze moisture out of the indoor space. And that overcooling leads to higher energy consumption, and that's a fundamental inefficiency with all the existing ACs. And desiccants are basically materials that can absorb moisture from the air directly. And when we offload this moisture removal load to desiccants, we essentially lower the load on the compressor. There is no more overcooling of the air that's being done. And that leads to a reduction in electricity consumption of air conditioning by anywhere between 30 to as high as 50%. Now, this solution is the most useful in production facilities where both humidity control and energy efficiency is very critical. So facilities like pharmaceutical plants, food and beverage factories are our major targets. So the product that we have built is an air handling unit, which is nothing but a customized, made-to-order central AC of sorts. And we have built it specifically for industrial dehumidification and clean room fresh air treatment applications. The main benefit to the end user being that we reduce their energy cost by 30 to 50% and also their carbon footprint. And we've also designed the product in a way that it integrates with the factory with all the utilities that is already there, the chilled water, hot water supply, and IoT is a part of it. We offer a wide range to cater to different industries. And this is our product. And we're also working on kits, liquid desiccant kits that go into air handling units so that existing AC and AHU manufacturers can integrate that into their products and launch desiccant-based air conditioning products. And the application of that need not be limited to only industrial cooling and dehumidification, but it is also applicable to commercial cooling, especially places where newer technologies like chilled beam-based technologies, radiant cooling, displacement ventilation, etc. are being used. And these technologies are not really great at managing humidity and are not applicable to places where humidity is very high. And by pairing liquid desiccant, we make these technologies applicable to those places as well, and then we unlock huge energy savings for the commercial facility. So yeah, that's about the product. This is our team. We are a group of grads from IIT Madras and IIT Bombay. Amongst us, there are chemical, thermal, mechanical engineers. And we have been doing research in liquid desiccants for close to 5 years now. We have built multiple prototypes, field-tested systems, demonstrated energy savings. And we have started deployments from the last 4 months. We have done 2 deployments already. There is another one that's ongoing, and then there are a few more in the pipeline. So our main ask here today is 2 things. So one is we are looking to scale up deployments over the next few months. So we are looking to have early adopters for our tech, mainly industrial dehumidification application. Next comes commercial cooling applications, especially when you're looking at newer technologies like radiant cooling or displacement ventilation, etc. And also, if you're an OEM looking to integrate newer technologies and launch liquid desiccant products, we would be, we would love to talk to you. And the second ask is we are also raising money. So yes, that is the end of my presentation. Open to questions.
Thank you. Any questions?
Quick question. One is differentiation. So you mentioned Blue Frontier and Transera. Like, how are you differentiating these from the international competition?
So Blue Frontier uses liquid desiccants again, and so they use a system that consumes a lot of water to operate. We, on the other hand, use a system that does not need water. We only need electricity. When I say they consume water, they evaporate water to a lot of cooling. And this the engineering is very different. So which means the size of the system is too high and all of that, which will not work in a lot of in industries in India where water is already a very valuable resource. Number one. Second is when we look at Transera, they don't use liquid desiccants, they use metal organic frameworks. So we, on the other hand, still use liquid desiccants that are organic, safe, non-toxic. So our engineering is fundamentally very different from how players in the US have been doing. That is number one. Second is based on the products, all the US-based companies build a product called DOAS, which is dedicated outdoor air systems. So they only focus on fresh air conditioning. We, on the other hand, have been building mainly for Indian markets, and here the best market for us is industrial dehumidification first, and then DOAS for application that uses, say, chilled beam displacement ventilation. So.
And I guess conceptually, the liquid desiccant, like, I mean, I'm familiar with solid desiccants, they take the water, but do you actually have to, is it a chemical reaction or is it just physical? And then do you have to like dump out the water or like, what's happening to the humidity or removing from the air?
Actually, we have two heat exchangers in our system. One is meant to absorb moisture from the air, the other one is releasing moisture from the air. So what will happen is there is no need to replace the desiccant or remove water or something. So the liquid desiccant would absorb water in one heat exchanger. It will automatically release water vapor in the other heat exchanger. So it's continuous operation, no replacement, easy to maintain.
Right, but I'm just saying if you keep releasing it to the second one, then you'll just keep adding water to the second one.
No, the second one will be exhausted into outdoor. Yeah.
Can we have last two questions?
So you were saying your desiccants are reusable, right? So
Yeah,
do
correct.
you have a lifetime on that? At some point of time, you will have to remove it, or how is it?
So the only contamination that we have in our desiccants are dust. We are already having an air filter to remove dust, and then we also have a liquid desiccant filter. So we would be doing a filter replacement quarterly, but not the desiccant replacement. Desiccant can stay for the lifetime of the
So the
equipment.
filters that you provide are your proprietary filters, or do you I can buy it from elsewhere?
The filters is not proprietary. Anyone, it's the common filters that's available in the market. Coming to what is proprietary, one is the liquid desiccant composition that we use varies from application to application. That is our core IP know-how. Second is our heat and mass exchanger design. We have spent close to 2 years perfecting the design, and also coming up with a way to manufacture the heat and mass exchanger. So that's an IP that we have. Third is the overall system design.
Okay, thank you.
Any last questions? Or okay, thank you.
Thank you.